Okay, here we're going to do question 10, and then we're going to do three more. We're in the home stretch. We're almost on the last page here. So first, there are 3 chocolate chip cookies, 4 oatmeal cookies, and 3 raisin cookies. What is the probability of choosing 2 oatmeal cookies if the first one's not replaced? So you're going to hopefully take the first oatmeal out. So to get the first oatmeal cookie, your probability is 4, because there's 4 cookies. Okay, so the probability is 4. Let's see how many cookies we have all together. So we're going to count the cookies. 4, 3 is 7, another 3, 10. 4 tenths. Now the probability of getting the second cookie is 3 oatmeal, because hopefully you've taken 1, over 9. The probability of 2 oatmeal cookies is 4 tenths times 3 ninths, which is like 4 times 3 is 12 over 90. And we can do our percents here. 12 divided by 90. Let's get our calculator. 12 divided by 90, 13.33%. Now, what we've been doing is called kind of conditional probability. So let's see, conditional probability, what is it? The conditional probability of event B given that event A has occurred is, well, it's the and divided by that. There's a formula. If you rearrange it, P A and B is PA. So this is the formula, PA, and then PB after A takes place. So this is if you rearrange the formula, what you do, you have to decrease it. So this is the formula here, 4 tenths times 3 ninths. 4 tenths would be A, and then PBA would be the 3 ninths. This is called the multiplication law for conditional probability. The probability of A and B occurring given that A has already occurred. Okay, let's try some examples. We're on the home stretch. We're on like the last page here. We'll bring it back. So let's take a look here. We'll do 11, and then we'll do the 12 and 13, and you guys will do 14 and 15 on your own here. So 11. Okay, a professional hockey team has 8 wingers. 3 of these wingers are 30-goal scorers or snipers. Every fall, the team plays an exhibition match with the club's farm team. In order to make the match more interesting for the fans, the coach agrees to select 2 wingers at random. So just randomly picks 2 wingers, okay, from the pro team to play for the team, for the farm team. What is the probability that 2 snipers will play for the team? So this one's kind of like order matters. They pick the first one. After they pick one, then they're going to pick another one. So in this particular case, order matters, even though it's not clear in the question. So let's see. 3 of these wingers are 30 goals. So 3 of the 8. So we're going to use that conditional probability. So 3 of the 8 wingers. So there's 3 of the 8 you can select to be the snipers. Now you're going to pick 2. So on the second choice, you got 2. You got 1 less winger over 7. So 2 over 7. Okay, 3 of the wingers are 30 goalmen, 3, and there's 8 wingers. Now hopefully you've taken one of them out, and there's 2 sevenths left. Okay, when you multiply this, you get 6 over 56. So 6 divided by 56. 6, go clear. 6 divided by 56 is pretty low, I'm sure. 10.71%. So 10.71% chance, okay, of getting 2 snipers on the team. 12 is one of my least favorite questions. I'll be honest with you. The wording is just terrible. Okay, the wording is just terrible, so I will go through it. So 12, but I do like 13. I do 11s. Okay, 13 is one of my favorite ones, I'll be honest. 12 is the wording's a bit off. So let's read it. And I got this question from somebody else, and there's a similar one in the textbook, and we have to cover it according to the curriculum. So let's read through it. Serena's computer sometimes crashes while she is trying to use her email program, Outtake. And I kind of wish they used like Gmail or something. When Outtake hangs, stops responding, Serena is unable to close Outtake without a system crash. In a computer magazine, she reads that the probability of Outtake hanging in 15-minute period is 2.5, with the chance of Outtake and the operating system failing together in any 15-minute period is 1%. So the failing together is 1%. If Outtake is hanging, what is the probability that the operating system will crash? So this is one of these conditional problems where out head take is hanging. So A has happened. Okay, we're finding PB. A has happened. What is PBA? What is the second one? So we're actually going to use this formula that they gave in this case. Again, the wording is just awful on this question. I know I got it from somewhere else. So we want to find the conditional probability. So we know that outtake is hanging, so A will be outtake is hanging. What is the probability, okay, that that B will crash? So we need to find the and part. So we're just using the formula. So we go in here, outtake and the operating system together failing anything is 1%. So 1 goes on top here. The 1%, that's where I got that from. On the bottom, okay, the probability of outtake crashing, so P is the outtake. So on the bottom, you put the 2.5. So you divide these two numbers. There's a similar question to the book. It's hint, not my favorite question. You guys usually know what that means. It's not my favorite. I just don't like the wording. So 1 divided by 2.5, 0.4, or 40%. I have to show it, though, so I did show one of these questions, but it's not my favorite question. My favorite is number 13. I'm going to even start on a new page. I like 13. I like the wording. So that was, if you didn't get it, someone can come up and take a picture. If they need a picture of that, they can go up and take a picture. But it's just 1 over 2.5 equals 0.4, 40. Now, I love question 13. So let's bring that up. A bag of marbles has 3 blue, 4 green, and 5 pink marbles. I used to love playing marbles when I was a kid, and it seemed to go out of fashion. I don't see kids playing marbles anymore. Okay, so they're all mixed in there. What is the probability of picking 2 pink marbles from the bag? So you want to pick 2 pink marbles from the bag, and we're gonna assume we can just pick them up. Okay, after we take one, then we're gonna take another. There's actually 2 ways to do this one. So let's look at 13A, picking 2 pink marbles. Okay, so first there's 3 pink marbles. We know there's 3 pink. Let's see. Oh, I made a mistake here. Okay, there's 10, there's 3. So what is the probability of picking, sorry, not pink. What is the probability of picking 2 pink marbles? It's different than mine here. Okay, 2 pink marbles. There's not 3 pink marbles. There's 5 pink marbles. So sorry about that. There's 5. We got 5 pink marbles. And we want to pick 5. And all together we have 12. 4, 9, 12. So 5 12s. And then the second one is 4 11s. Because we already used one of the pink marbles over 11. 5 times 4. Okay, 5 times 4. 5 times 4 is 20. 12 times 11. 132. Let's figure out what the percent is here. 20 divided by 132. 15.15%. There's a 15.15% of picking 2 pink marbles. That's assuming you picked a pink one and another pink one. Now, B part. What is the probability of picking a pink marble, a blue marble, and a pink marble in that order? So B, you're going to pick a pink marble first. There's 5 pink numbers out of 12. Then you're going to pick a blue marble. Well, there's 3. We haven't used any blue marbles, but we used one of the marbles. So look, it decreases by 1. So this time we use fractions, 3 over 11. Okay, now you pick another pink marble. So you pick another pink marble, so a pink one after. So there's 10 marbles left. So use 12, 11, 10. Another pink one. Okay, another pink one here. So 1 left. You already used a pink, so 4. So that was pink, blue, pink. Why did it go down to 4? Because you used one. You had one here. So pink, blue, pink. And then you figure this one out. So if you multiply the tops, okay, let's do the top here. Okay. So 5 times, let's do this, 5 times 3 times 4, 5 times 3 times 4, 5 times 3 times 4. 60 over 12 times 11, or 12 times 11 times 10. So 12 times 11 times 10, 1320. So 60 over 1320 divided by 1320, 4.54%. 4.5, hold it, 5%. You got to watch your rounding, so you move the desk times 100. That's 4.5, and that 5 makes that 5%. Now, C, watch the wording in C and how it's different than in B. Order matters. That's why we use fractions. Now, what is the probability of picking 2 pink and a blue in any order? So order doesn't matter in C. It does not matter in C. So in this case, order doesn't matter. So we have 5 pink marbles. Order doesn't matter. We're going to either choose 5, choose 2. Okay. And then we got 3 blue ones. We choose 1. And how many of the last one? Green ones. We have 0 green ones, so we could put 4 0 green ones. So we go back to the other. See, when order doesn't matter, we do it this way. The order you pick them doesn't matter. So the other one, the order mattered. You had to pick pink first. You had to do blue second. You had to pick pink third. And the other one, altogether, there's 12, 3. So you don't do fractions, you do these choose. There's 12, 5 plus 3 is 8, 12, choose 3. Now, order doesn't matter, so you do this. Okay, you put that all in the calculator. So let's do 5, choose 2. Put that on the side. 5, choose 2. 5, choose 2 times 3, choose 1. The other one doesn't matter. Okay, it's 5, choose 2. And 3, choose 1, you get 30. And 12, choose 3. Again, the other one is 1. We know the other one's 1. Okay, 30, 12, choose 3. So 12, hold on a second, choose 3 over 220. Let's see what that is. 30 divided by 220. 13.64%. Okay, you can now stop the video. Okay, and then do the last questions, and I'll put the last questions up with the last video. But do them on your own. Do 14 here, 15 on the back, and then I'll put the answers to the last 2. Okay, on the last video.